Hello guys, in this video I will be explaining how to graph piecewise functions. Let's take a look at the first function. The first function is composed of two constant pieces that will be represented by horizontal lines. Remember, when there's a constant function like y equals a constant line, a constant number, then the graph will be a horizontal line. So I will be graphing two different horizontal lines for two different intervals. So what are the intervals? X being less than or equal to -1 and x is greater than -1. So for every interval, I have a different function. So for x equals -1, let's find -1 here. My function is 4. Y is equal to 4. So I will be graphing a horizontal line here that will be graphed on the left side of -1. I won't be graphing 4 from negative to positive infinity. It's not extending in both directions. There is a restriction. This is only true for x values less than or equal to -1. So we have to start graphing from -1 and graph left side of -1. The left side of -1 will be represented by y equals 4. What about the right side? On the right, we have -2. Find -2. So starting from -2, you make a horizontal line that covers the right side of -1. So for numbers greater than -1, we should graph this -2 for right side of -1. So we have two different rays, two different horizontal lines, one of which is for region less than -1, the other one is for greater than -1. Less than or equal to -1 means the point is included. Greater than -1 means point is excluded at -1. So we have to pay attention to the boundary lines. So that's the way of graphing constant functions. And in this topic, we will be also talking about domain and range, which is pretty essential. So domain represents uh, the possible x values. What are the possible x values? What is the smallest x value? Since this part of the graph is extending to the left, that part is extending to the right. So this part covers every number till -1. That part covers every x value bigger than -1. So in this point, in this particular point, we have a field point here. So every x value is possible. All real numbers, less than -1, greater than -1, and including -1 are included. So we will say all real numbers will be the domain. What about the range? For range, we look at the possible y values. There is one y value here, -2, and there is another y value here, 4. So we just have two numbers. There is no region, there is no interval, just -2. So I have to use the curly bracket. -2 and 4 will be the range for this piecewise function. Let's take a look at another example. So what if my functions are not constant? They may be linear, quadratic, cubic, exponential. Every function is possible. So in this case, we can't make the graph randomly like this. In this question, we are sure that it is a constant number, so it is represented by a horizontal array. But here, we know it is a straight line, but what kind of straight line we have, how inclined is it, is it increasing, decreasing? So in order to figure this out, we have to make a table. So remember from the previous section chapter, we were making table of values to graph a function and plotting them on the coordinates plane. We will be doing the same thing. So we have two different cases. For every case, we're going to make a table. So for the first case, x is less than 2. What is the y value? The function, the function is negative 3x. When x is less than 2, the y is negative 3x. That's the first situation. The second situation, when x is greater than or equal to 2, then y is x plus 3. So I'm going to make two different tables. The first table, let's pick values less than 2, including 2, 2. 2 is the boundary line. We have to be careful about the boundary point. We have to use the boundary point whether it's included or not. 2 is discluded, but still we have to use it to plot it on the coordinates plane. When we use it, we will be using an open circle. We won't be including this, but we have to use it. So let's pick 2 and numbers consecutive x values less than 2, like 1, 0, -1, -2, and so on. So that's a linear equation. I don't have to pick more points. 2 points are enough, actually. I don't even have to use the third point. So I just have to plug in these one by one. 2 for x, -3 by 2, 6. 1 for -6. 1 for x, -3. 0 for x, 0. And so on. So I'm going to plug these points on the coordinates plane. 2, -6. 2, -6 down here. And remember, since x is less than 2, I won't be including 2. So I have to use the open circle. 1, -3. 1, -3 here. And 0, 0 here. And so on. As I give x values, I will have y values going in this direction. So I have to know how the graph looks like first to connect the points. It's a linear function, so the graph is a straight line. So I will be graphing a straight line by connecting those 3 points. I should get a straight line. So let's connect them. Get a straight line. So that's my first part of the function. The second part, let's do the same. Pick some x values greater than or equal to 2, including 2. 2 is included. So when I point 2, when I plot 2 comma something, I will be using a closed circle. 2 greater than 2, like 3, 4, and so on. I don't have to keep going. 2 or 3 points are enough. And plug in 2. 2 plus 3 makes 5. Plug in 3. 3 plus 3 makes 6. Substitute 4. 4 plus 3 makes 7, and so on. Let's plot these points as well. 2, 5. 2, 5 here. Remember, the point is closed. 3, 6. 3, 6 here. 4, 7. 4 here for x. 7 for y here. Like this. Since the line is linear, I have to use a straight line. Connect these points by using a straight line. Okay, connect them and extend the line. So this is how our piecewise function look like. And the second thing we need to do in these kind of questions is talking about their domain and range. Let's talk about domain and range. So you can figure out domain and range by looking at the graph. Look at the graph. I have two pieces. Look at the left piece. The left piece is extending to the left, so it covers every x value until 2, right? 2 is excluded. Look at the right piece. The right piece is extending to the right, so it covers every x value on the right of 2. At 2 exactly, one point is excluded, one point is included, which makes it included. So at 2, I have a value 2. So I have numbers less than 2, greater than 2, including 2. So all real numbers are possible. So can I find domain by not using the graph? Yes, I can. I can use the domain by not using the graph, by looking at the question. In the question, after if part, the interval part is represented by input. So input means domain. The x values represents domain. So when you look at the domain part, we have numbers less than 2. You can make a number line to see it clearly. Numbers less than 2, you shade the left side of 2. Numbers greater than or equal to 2, you shade right side of 2 including 2. So there is no gap. Everything is included. Less than 2, greater than 2, including 2. So all real numbers are possible for domain. What about range? For range, we should look at the y values. What are the y values? The functions are heading up, goes to infinity on the positive direction, but on the upper part there is a limitation here. There's a restriction. The function is not going down. The function starts from -6. So before -6 we don't have any graph, so we don't have any y value. It starts with -6, which is discluded. Remember, there is an open circle here. So from -6 to the positive infinity exclusive. So I have y values greater than -6, and it goes to the infinity. So that's the range. What about figuring out range from the function? How do I do that? So the before if part, function part, is the output part. The output means range. So the y values are the range values. But unlike x, we don't have a numbers here. We don't have numbers here. We have functions. So we have to know the values for these functions. So I just have to use the tables then. Since I don't have numbers here, I have to use the tables. Let's refer to tables. So in the table, y part is the range part. This part is range. This part is range. So let's use the range part, the y part. Make a number line as I did for domain. So for the first part, from -6 to, where does it go? It goes to the positive infinity. -6, -3, 0, and so on. Numbers are increasing, going to positive infinity. So from -6, discluded, to positive infinity. So you shade the right side of -6. What about the second part? In the second part, numbers starting from 5, 6, 7, and it's increasing, heading to positive infinity. So from starting 5 on the number line, shade the right side of 5. So which numbers are shaded? Numbers from -6 to positive infinity are shaded. So this represents our range.